Hello everyone, and a warm welcome to the Directions Live online webinar series by Esri Malaysia webinar. My name is Caleb Sang, and I'm your host for today's session. Now, today's presenter is Muhammad Afif Abu Bakar, our industry consultant with the enterprise consulting team of Esri Malaysia. He'll be leading the webinar today. So without any further ado, I shall pass the presentation to Afif. Over to you, Afif.
Okay, thank you, Caleb, for the introductions. So hello, everyone. I'm excited today actually to share with all of you on the topics of these GeoAI workflows with ArcGIS Pro and how we can actually see how you can actually bring automation in your daily operational tasks, and how we can actually start to answer questions like how you can actually automate in terms of extracting building footprints, in terms of extracting the road layers, in terms of doing an automated tree counting, some things like that. So from there, we can actually leverage, fully utilize in terms of your investment in terms of drone imageries, satellite imageries, or CCTV cameras, for example. So without further ado, let's jump to the artificial intelligence. So what is actually an artificial intelligence? You've probably seen and heard in terms of AI a lot recently. So there's a lots of hype and confusions around it. So when we actually talks about artificial intelligence, what we can actually visualize in our mind is that we are seeing things like robotics in terms of self-driving cars, for example. But actually, what is actually artificial intelligence is it is actually a science in which we are actually training the machine on how to actually achieve human level of intelligence. So and then we have machine learning, which is a subset of artificial intelligence. This is where we're actually working with data. From the data, we actually learn in terms of how to actually extract certain information, how we can actually do classification, extract certain patterns from the data sets. So this is one part of the machine of the artificial intelligence. And then from there, we have deep learning. Deep learning is actually a deeper field inside machine learning, and in which we start to actually incorporate deep neural networks methods, which is mimicking how actually the machine can actually mimics how the human brains works in terms of learning things. So when we talks about GeoAI, why actually people talks about GeoAI, why people are starting to get interested with GeoAI. So I have one one inspiring story to share with all of you today. This is actually being done by a public authority of civil information in Kuwait. Basically, they have this Kuwait Finder apps over there, which is actually providing a base map for the citizens, and the citizens are actually opting for Kuwait Finder rather than the Google Maps. This is because of the rapid updates of the data within the Kuwait Finder itself. So how they actually achieve this? Basically, they started with an R&D project, and they started to actually explore in terms of how they can actually use different models of different deep learning models to actually come up with buildings and road extractions. So after they have actually quite matured in terms of training the models and applying the models, they actually deployed for their own daily works. So as you can see here, previously it is actually being done as a manual digitizing works. They did the manual entry works, and it took about 119 days to actually do this. But after they actually start to employ deep learning technology, they actually reduced the time for them to actually extract all these buildings and all these road networks into 1.5 hours of processing and 2 days QA/QC job. So you can actually see here, we have about 111,000 of buildings and 78,000 of street that actually has been automatically extracted for this particular application. So after they actually start to evolve in terms of increasing their infrastructures capability, and from there, before they can actually conclude that before this, they need 4 people, 5 hours a day, and 1 year for them to actually get the information for the whole country. But now with deep learning within ArcGIS, the whole country can actually be done under 30 minutes. That is how significant how they can actually achieve a same amount of quality, and they actually did what they actually did in terms of their daily operational works, but in terms of automations. that's how GeoAI can actually help them with. And then another example that I have here is basically on how you can actually use GeoAI also for point cloud classifications. So basically, this is a joint collaboration between Esri Australia and AAM, which is a LiDAR data provider. So from here, before this, when they want to actually extract these poles and wire lines data from point clouds, they need to have about 50,000 man hours per year of manual leveling to do this kind of job. So when they start to actually employ deep learning models, which is a point CNN within the ArcGIS platform, they can actually achieve the same level of quality of data. So this is actually an automated point cloud classification of wires and poles that actually tackle their challenges. So one of the challenges is that when the wires actually comes together with the point clouds of trees. So actually this how actually they actually discriminates between points that actually belong to the wires and points that belong to the trees. That is how they actually leverage on the use of GeoAI for that. So it will actually improve in terms of the quality of the data, and also reduce in terms of number of errors that have been done by manual editings, and it can be done as rapid as possible. And then another application on how we can actually use GeoAI is in terms of disaster response. So how can we do this? One is we can actually detect in terms of damage structure. And let's say if you don't have any building footprints available, we actually extract the building footprint first, and then we start to actually classify it into undamaged or damaged structures. And then if you have if let's say you don't have any root layers, we can actually extract the root layers, and then we start to actually classify it whether it is a damaged or undamaged roots. We can actually start to incorporate other element, which is we start to define whether it is an obstructed root, for example. So this kind of information actually very crucial for the first responder. So during the disaster response process, first responder need to actually know in terms of the area that they need to actually prioritize. So the damage structure actually has provided us in terms of quantifications of certain area and how they can actually prioritize which are the area that is actually highly impacted by the disaster. So aside from that, from the damaged road layer, we can actually start to plan which area is actually obstructed and which area that the first responder can actually provide service. So from there also, we can actually start to identify the areas that is unserviceable by the first responder, which area that are being disconnected due to the damaged roads. So from there also, when we start to actually incorporate the field mobility apps within the ArcGIS platform, we can start to actually see in terms of collaborations, in terms of the first responder at the field, they can actually start to use the mobile applications, and then the staff in the office can actually start to visualize in terms of the operations using the ArcGIS operation dashboard. Okay, another example that I have here, I think everyone here actually seen that some of the people are actually doing those traffic surveys on over the roads, and so this is actually being done by the transportation department. On the left side, basically these are the surveys that are being conducted on the road, and on the right side is basically a daily average traffic of the traffic survey that has been conducted. So as you can see here, basically there's when we actually start to zoom in into the map, we can actually see that they're actually quantifying the numbers the numbers of cars or any vehicle that actually passing over certain junction. This kind of information is actually very crucial for the transportation department in terms of traffic simulation, for example. And then in terms of, let's say, they want to actually approve a certain roadworks projects, whether it will actually highly impacting the traffic. So they will actually need this kind of information to actually incorporate into their decision making. So how can we actually automate these things? Basically, from your CCTV, through deep learning, we can actually start to detect numbers of cars. We can actually start to detect other things. We can start to classify in terms of the cars and trucks, buses, motorcycle, all of this. And then we can actually incorporate this into an operational dashboard. So rather than you have a paper-based map for your reporting, now we actually have all of this information in a geodatabase in which you can actually use it later on for your own analysis. Okay, so basically the application does not stop over there. So we have other application also over here. So you can actually see we can actually do land cover classification in terms of pipeline encroachment. You can actually identify root cracks over the imageries. You can actually start to do individual tree counting automatically from the imageries. The rule of thumbs over here is that if we actually able to detect a certain object on our imagery within 1 or 2 seconds, that is actually good enough for us to actually train the machine to automatically detect it for us. So we are still actually exploring on other applications on how we can actually apply these deep learning technologies based on your industrial needs. Okay, when we talk about AI or GeoAI, basically in terms of Esri, it is not any particular products. There's no such thing as ArcGIS GeoAI. Basically, it is a technology that we actually applying across our ArcGIS platform. So as you can see here, basically we have actually embedded these features into ArcGIS API for Python. And then we have ArcGIS Notebook, which is a resemblance of the Jupyter Notebook. So you can now actually do your Python's programming using our ArcGIS notebooks within the ArcGIS platform. And then the one that I would like to highlight today is how we can actually start up with using this deep learning technology within the ArcGIS Pro. So historically, Esri is quite Esri or ArcGIS technology, our platform itself actually has quite matured in terms of machine learning works, in which you have actually used it for classification works, some prediction analysis, clustering analysis. For example, you want to actually finding patterns or any outliers within your imagery. So we actually have dedicated tools for that. But now we are start to venturing. We are putting a lot of work into developing tools for deep learnings and actually embedding most of the available deep learning models within our deep learning capability. And another one that we are actually venturing into is that in terms of natural language processing. This actually can be done when you want to actually extract non-structured data and unstructured data from let's say from online documents or from the Twitter live feed, for example. So this is how we actually retrieve that kind of information to be inside our geodatabase. Okay, in the context of this end-to-end geospatial AI lifecycle, basically, I would like to say that I believe that it's actually ArcGIS provides you with end-to-end solutions for these GeoAI applications. Okay, for example, here you can actually see you can start to incorporate your own imageries. For example, the satellite images that you have, you can actually incorporate drone imageries, CCTV videos, images that actually coming from your mobile devices, for example. So from here, actually, we are providing data access. You can actually access your data from external sources, or maybe you want to actually take your data from image server. So we can actually take the data and manage it within our platform. And from that imagery management, we start to actually label our data. So from this data labeling, we actually identify what are the objects that is of our interest, and from there we start to label the object. It is the same way on how you actually do the digitizing process, and then from there we start to prepare the data. In this data preparation stage, we actually prepare the data into a smaller chunks of imageries. We call it as image chips, and from this image chip is actually work as an input for your model training. So from here, we start to actually go to the model training part. Actually, in terms of model training, I think this is the sweetest spot in terms of package that we are offering into ArcGIS Pro, because 3 to 4 years ago, all of these deep learnings models is basically accessible only by developers. You need to actually hard code everything to actually come out with these deep learning solutions. But now we have actually prepared it all into a geoprocessing tool. So you can actually use it in the user interface kind of things. You can actually start to actually input your data, define your parameters within that geoprocessing tool. And I would like to say that the model training parts, that there's no such thing as one model that actually fits everything. You need to actually train a specific model for your own particular application. I give you an example. Let's say, for example, you are working on oil pumps data over the imageries. So you want to actually extract this data automatically. So you actually start to label your oil pumps. But when it comes to other areas, there might be a different shapes or different sizes of oil pumps. So the model that you've created earlier might not be suitable for another imageries, but and it will actually reduce in terms of the accuracy of the model. But you can actually retrain the model. The existing model can be used as a part of a pre-trained model to actually develop another model to actually compensate in terms of other sample size for a larger sample size. So I can actually see here that this data labeling process, the data preparation part, and the model training part is an iterative process. So you actually start from somewhere. You're getting started with deep learning. You start to build your first model, and then from there you can actually retrain your model later on to actually improve its accuracy and actually able to get data that is actually sufficient for your operational needs. So in terms of once your model has are ready, you can actually start to deploy your model to production. You can actually deploy it to enterprise to a server-based environment. So you can actually conduct server processing over there using raster distributed processing within the image server, for example, to speed up the process. And then you can everyone from your organization can actually consume the model, and you can actually collaborate together with the model to run this inferencing at scale. So you can actually let's say you have a small sample, and then you do the model training, and then you apply back the model to a larger extent of the area or to the other area to actually automate in terms of object detection process. So from there we have all of these base data sets. We're actually extracting we actually maximize the potential on how we actually extracting features from imageries, and from there you can actually come up with lots of data set, and we can actually start to analyze all of these data sets and take action on that. So I will actually go through with you some example. So data labelings over here, let's say we have a drone imageries. So you want to actually label up your data. As I mentioned earlier, you can actually start to label up your individual data. This is how actually we want to prepare the data before we export it into the model trainings. So now we actually label this thing as coconut, for example. You can actually see on the left side, we are actually now we're exporting the data. And in terms, after we actually has export the data, this is actually the data looks like the image chips that I mentioned earlier. It will actually appear as a small chunks of your whole imagery that's come together with a metadata that actually label up your features. So this is how the data preparation works before we actually input it into the model training. So this is the model training parts. Once we have the samples data ready, now we want to actually start to train the deep learning model. So we have a specific tool for that under the deep learning package. So you can actually see we have a train deep learning geoprocessing tools to actually train your model. I will actually go deeper into this in the demonstration. Okay, and then once we actually finish with our model training, we can actually start to deploy the model to a larger extent. So now we can actually see that we have actually applied this coconut trees identification for a larger area. So you can actually start to see there's some of the missing trees over the areas. That is basically what I've mentioned earlier. You need to actually there are two things to actually determine the thing. You need to have a larger number of samples for that, and then you need to actually train the model for a longer period of time to actually improve in terms of accuracy. Okay, so let's go to the demonstration parts. For the demonstration part, things that I will actually demonstrate today is that how this is actually an area that actually impacted by fire damage. This is over the Woolsey Canyon, somewhere in Los Angeles and California. So over here, we can actually see these are the area that actually impacted by the fire damage. So over here, we can actually zoom into the area that have lots of building. So let's say, for example, you don't have any building footprints available. So you want to actually start to label up our building footprints. So over here, you can actually see that we can actually use the classification tools, label objects for deep learning. So under this label object for deep learning, we start to actually label up our buildings. So we start to label the buildings. Let's say this is an example, I classify this as building. And then let's say if I actually prepared, I've actually digitized the whole area. This is actually how the sample looks like. So this is maybe it can actually come from a ready data. So once we have this data, this training sample available, we can actually start to use a geoprocessing tool called export training data for deep learning. So now we actually input our raster imageries, which is the imageries in the background, and then the output field. We start to specify the output folder. And from here, we actually input our feature class, which is a building we'll see. This is actually the buildings that we've actually digitized earlier. So you can actually customize the parameters in terms of tile size, in terms of stripes. These are actually the parameters that actually define the image shapes. And from here, we can actually select the metadata format that is actually suitable for your own deep learning applications. So once I actually run this tool, we will actually get a training data, something like this actually. So you can actually see inside this folder, these are the image chips that I've mentioned earlier. So these are the image chips that we will actually be used as an input for our model trainings. And then once you come back to this imageries, we will actually start to conduct another geoprocessing tools, which is a trained deep learning model. So, okay, before we go deeper into the model specific for this particular applications, I would like to show to you that actually in the current release of the ArcGIS Pro 2.8, basically we have actually supported a huge numbers of models into the trained deep learning models. So as I mentioned earlier, this trained deep learning model is in a geoprocessing tool, and you can actually get access to about 18 of deep learning tools with specific applications that you can actually use inside this trained deep learning model. So let's get back to the training sample data that we prepared earlier. So once we actually have the folder just now, the image chips, we actually input it as a training data, and we specify the output model, and from here we specify the model parameter. So as you can see here now, inside the model type, basically it is selected specific to the types of data that I've prepared earlier. So from the previous trained deep learning model, you can actually see there's about 18 of models available, but now this one is actually specifically designed for this sample of training data. So we can actually, this is actually the part where you can actually incorporate previous model as a pre-trained model. So let's say you have an existing model before, you can actually input it as a pre-trained model to actually improve that model. But let's say this is a new model, so we start to actually run this model. So we can actually get another folder here, which is the footprint model. So you can actually see here this EMD file, which is the Esri model definition file. This is actually the file that is being created after we generate the model. So from here, we start to actually apply these deep learning models to a larger area. Okay, let me open up the. So as you can see here, we have another tools called as a classify pixels using deep learning. So over here, the parameters that we specify is the input raster that we want to use to actually extract the building footprints, and then we specify the output classified raster, and we actually start to import in the model definition that we specified earlier. This is actually the model that I've shown to you just now. The EMD file, and then we start to run the model. So after we run the model, how actually the output looks like. So we can actually see here the example. These are basically how the output looks like. It is nice, but it doesn't actually resemble the geometry of the buildings. So from here, ArcGIS Pro also offers other tools, other geoprocessing tool for you to actually regularize these building structures. So we can actually apply a regularized building footprints under 3D analysis. So from there, we can start to get an output of something like this. So now we have a more realistic view of the building footprints. So let's not stop over here. once we have the building footprints, we want to actually start to classify in terms of damage and undamaged structure caused by the fire damage. So again, we will actually we will actually start to actually come up with a training sample for the building damage. So I will show you over here. So you can actually see here, these are basically the sample data that we prepared for the damaged structure. So we start to actually classify the structure as damaged and undamaged structures. So this is the sample data that we will actually feed into the export training for deep learnings. So from this export training data for deep learning, we specify the input raster and then the output folder that we actually store the image chips, and then we specify the input as a damage training sample, which is this one. So we define the parameters and then we start to run the tools. We actually get another training chips over here, the building the damage training data. So the same things, we have the image chips for the damage and undamaged classes. So from here, we start to actually input the data into the trained deep learning model. So from here again, we specify the damage training data together with the output models that we want to come out. It is a separate model. The one that we did earlier is for the object detection, and now we want to actually classify whether it's a damaged or undamaged structures. So we start to specify it. As you see here, the model type actually specified as object detection. So we will actually use this object detection model to actually train this training sample data. So once you actually train the sample data, we will actually get another models specific for building damage model. So you can actually see here we have Esri model definition file and this deep learning package file. So both of these files actually supported within ArcGIS Pro. So within this detect object for using deep learning. So previously we used classify pixels, and now we are using the detect object using deep learning. So we specify the input raster, we specify the output detector objects, and then we actually start to incorporate this EMD or DLPK file into the model definitions. And once we actually run the models, we can actually see the inference result actually appears like this. I will show you. So basically what we did earlier is that during the training of the sample data, we only label this area as the sample data, but now we actually have upscaled this damage and undamaged structure classifications over the whole area. So basically from this kind of information, you actually come out with a ready products for decision making. For example, you're working as a first responder. This is actually a crucial information for you to actually start to prioritize which are the areas that are heavily impacted by the fire damage. So you can actually see over here, this has been actually classified as an undamaged structure, as a damaged structure. This one actually classified as a undamaged structure. So from here, even for example, the insurance company can also verify in terms of how claims are being submitted to them based on this kind of information. So what we have actually gone through now is that we have actually did an overall end-to-end solution from imagery management, uh, labeling to the training of the sample data until the object detection for the whole imageries. So this is how you can actually speed up the process of extracting all of these features over a larger extent of area. So basically, if actually you are doing this in your local machines, so it will take about, depending on your GPU, it will actually take about 4 hours to 12 hours, for example, to actually get for the whole imageries. But let's say if you are utilizing servers to actually process all this data, it will actually takes about 30 minutes, 20 minutes to actually finish in terms of this larger extent of area. So that is how we can actually improve in terms of our daily operation needs using GeoAI technology. Okay, we finished with the demonstration part. So we'll come to the key takeaways part, whereby the first point that I would like to highlight here is that GeoAI is the first step toward creating a decision-ready product. As we've shown earlier, you can actually use it for decision-making purposes. And the potential of GeoAI capabilities in replacing manual and tedious time-consuming tasks to actually boost in terms of your organization efficiency. So the one personnel who are actually doing the digitizing works can now actually start to explore in terms of how they can develop themselves in terms of doing modeling processes. So they actually you can actually start to leverage in terms of human capitals in terms of your organizations. And then ArcGIS Pro also provides an end-to-end solution for imagery GeoAI workflow. So I think basically that's all that I can actually share for today's session. So I'll actually hand over back to Caleb to conclude the session. Back to you, Caleb.
Well, thanks, Afif. That was a very interesting presentation on the possibilities through GeoAI. So we have had a couple of questions come through. So if you have been listening intently to Afif and you haven't had a chance to type out your question, there's still time. So you can do that just in the questions pane on the right-hand side. Now, to kick off, Afif, there's one question for you.
Okay.
What is the difference between object detected from deep learning and object detected from image segmentation?
Okay, an interesting questions. Okay, as I mentioned earlier, basically deep learning is a subset of machine learning. So we have been doing segmentation, image segmentations before in terms of machine learnings. So in image segmentation, basically you specify certain rules to actually achieve in terms of output that you actually need. For example, I give you an example. For example, we want to actually extract building footprints from a multi-spectral data together with together with a digital elevation model data. So we start to actually specify the rules in terms of building height. We specify in terms of building edges over there. So we are actually specifying on how actually image segmentation can be done. So once we actually run the model, we actually get when we actually run the segmentation, we get the output. So the difference that when we're working with deep learning, we are actually giving the models the criteria of our data in terms of this label of the training data. So from there, the model itself will start to actually learn in terms of certain criteria on the imageries that actually resembles a building. So that is basically the differences between the segmentation process and also the deep learning in terms of how we actually interact with the machine in terms of determining the best condition to come up with our outputs. I hope that's answered your questions.
Thanks, Afif. That actually taught me something as well. And there's a second question coming through. Can you please highlight on the important updates on the deep learning modules in ArcGIS Pro 2.8? To you, Afif.
Okay. For the importance updates, let me share to you back to my ArcGIS Pro. So I actually have prepared some of the list of the model available in terms of ArcGIS Pro for the ArcGIS for developer, ArcGIS API for developer. So inside here, you can actually see there is about 25 models actually available inside ArcGIS API for developer. So this model is actually the model that actually you can actually use for different kind of applications. So from ArcGIS Pro 2.7 to ArcGIS Pro 2.8, basically they have actually includes a lots of this model that is actually available previously inside API for developer into deep learning. So you can actually see previously from my explanations, we can actually see the difference over here. These are the models that are currently available inside the geoprocessing tool. You can actually use it easily within this train deep learning geoprocessing tool. So from here, we can actually see some of the things. For example, like point CNN is not available yet inside the model type. For example, the object tracking, like the CMS is not available yet, but in the future, this is actually the model that will actually be incorporated inside the trained deep learning model. So I think that is the huge differences between this between ArcGIS Pro 2.7 and 2.8. Another thing that I actually noticed in terms of deployments of these deep learning frameworks. In ArcGIS Pro 2.7, for example, you need to actually deploy your own deep learning frameworks to actually enable your ArcGIS Pro to do model training and also to do inferencing. But now, actually, in ArcGIS 2.8, once I've installed ArcGIS 2.8, once I've updated to the ArcGIS 2.8, I can straight away use the deep learning models. I think that's other differences. Back to you, Caleb.
Thanks, Afif. That is a lot of updates and a lot of useful updates. Now, there's a third question coming through. I hope you can answer this. Is video object detection applicable to a video taken from a UAV? And to you,
Okay.
Afif.
In terms of videos taken from UAV, we actually inside image analysis under ArcGIS Pro, we also have we also actually support in terms of full motion video. So basically, we actually conducts the preparation part of the full motion video using the tools available under FMV geoprocessing tools, and then there is actually the data preparation part, and basically. Let me show you one of the example here. I have one of the example in terms of, okay, in terms of, okay, basically we have a few examples available. Let's say after this we might actually show in terms of how full motion video can actually be used to actually together with the ArcGIS API for Python to actually extract all of these informations from the video cameras. Basically, it's possible. Yeah, I hope that answers your question.
Thanks, Afif. And perhaps this can be something we talk about in the next webinar, I suppose.
Yeah.
We have some time left, so we'll continue with the questions. So in case we would like to detect objects from a video taken from a UAV, is ArcGIS Pro supporting the whole workflow of object detection, or do we still need to integrate with external deep learning frameworks? To you, Afif.
Okay, I think this is almost the same as the previous question. Basically, as I've mentioned earlier, we have a full motion video actually supported within ArcGIS Pro. So from that, let me actually find one examples here that you can actually. This one is actually more on the vehicle detection and tracking using deep learning. So you can actually access this within ArcGIS API for Python, for example, because some of the model is actually available within ArcGIS Pro. But in terms of object tracking, currently the CMS model is not available within ArcGIS Pro. But we can actually do something like this. Basically, we will actually have access to all of the examples of the ArcGIS API for Python for you to actually use the management within the ArcGIS Pro, and then you start to actually use the model that actually been the flows that actually been developed under this ArcGIS API for Python for you to do the classifications of the objects, and then from the video itself you can actually detect using the model available within ArcGIS Pro within the ArcGIS API for Python. So I hope that answered the questions. Back to you, Caleb, for that.
Thank you very much. And I hope that answers your questions. I think that's all the time we have today. And if we have not answered your questions, we will surely reach out to you with the response through email. And we really love your feedback. So we hope you take the time to fill out the brief survey that you will see pop out at the end of the session. Further feedback or questions can be sent directly to events, that's events, at esrimalaysia.com.my. Finally, if you would like to rewatch this webinar or share with your colleagues, the recording will be shortly available on the Esri Malaysia events page. Thank you very much, Afif, and thank you everyone for joining us. And we will see you for the next Directions Live online webinar series.
Okay, thank you everyone.
Thank you.